Is up, legends. Today we are looking at section 2. We've done a little bit of the basics of what actually indexing is and why we need it, and today we're actually going to get into indexing and doing something very useful. So we'll get to that in a second. First, setting up our own indexer, querying it, what that all means, but just a super quick recap, the basics on indexing. You index data so that you can access and search it more easily. Blockchain data currently is stored by all the nodes in the network, and it's stored in this append-only block format, and sometimes searching through all of these blocks to find the information that you actually care about can be quite slow and cumbersome, and indexing is sorting through that information, storing it in a way such that it's meaningful for you, right? So instead of all the data, a needle in the haystack, indexing is you going through all of that data in the blockchains, extracting the data you care about, and saving it perhaps into a database so that you can use it or run some logic on it. And to get onto section 2 today, which is more actually setting up an index and doing something useful, I want us to put ourselves in the foot of, say, a team actually wanting to do something. So let's imagine we are, say, the Eigenlayer team. Eigenlayer is a really popular project. You've probably heard of it. All to do with liquid restaking, etc. And if I go ahead and look here at Eigenlayer, they have a bunch of different contracts they're deployed on mainnet. I think we should look at, say, the strategy manager, for example. And just so you know, if you look at Eigenlayer, I've pulled up their repo strategy manager. What the strategy manager does, this is the primary entry and exit point for funds going into and out of Eigenlayer, right? It's letting you actually deposit. So what we want to do is, how many people have deposited? How much are they depositing? Which strategies are they depositing into? How do you answer this question if you've developed this code, you've deployed it as the Eigenlayer team, and you can obviously navigate on the block explorer and see there's a whole lot of people that are depositing in here. You can see in this events tab some of the things that are happening. There's some withdrawals over here that are being queued and completed. There's probably some deposits, but this is really just giving us the latest 25 events, and we can't make as much sense of this data. It's not decoded. How on earth do we go about having something meaningful such that we could maybe show something on the Eigenlayer front end or get some statistics from it? So that's what we're going to get started with today. And there are a ton of different data services, indexing frameworks. Really, there's a lot you can check out. And for example, Primo Data lists a ton of different guides and different companies, landscapes, frameworks, etc. We're actually going to be using Envio, really fast modern framework for indexing. And I'm going to show you how quick and easy it is to get going. So we'll get into that. And just a reminder of what we're actually doing is when people deposit in this Eigenlayer strategy manager contract, you'll see there's an interface kind of defining this event, but basically this event is emitted deposit. Who is the staker, what is the token, what is their strategy, and what shares are they getting? And you can come read this in more detail in GitHub, but essentially when someone's calling that deposit function, this is being emitted, and we want to collect all of these events and transform them so we could answer questions like what has been the biggest deposit, or who's made the most deposits, things like that, which a lot of different stakeholders would be actually interested in. So without further ado, let's actually get to indexing all of this. It will help us learn a little bit more about what indexing is, how to do it, all of those kinds of things. So for you to get started at home, it's super simple, and we'll go through it now. But docs.envio.dev, there's a no-code quick start on the left, and it's really just running this envio init command. There are a couple small prerequisites you need. which is Envio, Node.js, PNPM, Docker, things that should be really simple to install, especially if you have a bit of a development background. You can go check these out, but really that's just a Google away on how to install these. If not, most of you already have installed all of these. So I'm going to start the process by running Envio init and show you exactly how we're going to index this entire contract into a database and have useful data in a matter of minutes. So very quickly, I'm in an empty folder over here, you can see, and I am running Envio version 37. You can see by the time you're watching it, maybe it's a later version, 38, something like that. That's just the version I'm running right now. And all I'm going to do, as mentioned, is run this envio init command, which is going to quick start generate an indexer for me. I'm going to call it eigenlayer indexer. I'm going to put it in here. And there's 3 different languages you can use. I would generally just recommend default to TypeScript for start. Rescript's extremely useful. It's very functional. It's a bit more advanced. It's something that if you're familiar with, go for it. If you don't know what it is, you might not want to start with it right now. And yeah, we're going to simply use this contract import option here. We are going to use the block explorer, Ethereum mainnet, and all we need to do is actually go and grab this address, the eigenlayer strategy manager. We paste that address in, and what's going to happen is it's going to retrieve all of the events and ask us which ones we like to index. Nice. So just like that, here's the list of all the events. We can go through and select which ones we actually want to index. Let's keep it simple and just index this deposit address. This deposit event, as that's really, I guess, an interesting one to start off with. So I can just select this, and now we're just indexing all of the deposit events into the eigenlayer strategy manager contract. All I need to do is hit enter. I'm finished. There are options to index multiple contracts and go on multiple networks. It's really nice, but for now we'll leave that and we'll just index this eigenlayer strategy manager. And there we go, just like that in a couple seconds. What's actually been done for us right now is an indexer has been generated. So I'll show you what the code actually looks like by opening up a code tab, and over here we'll have our nice tab of everything that's happening. But before we get into the actual code, I just want to show you how powerful this is and what's actually been generated. So right now, bearing in mind this has taken a minute to auto generate the indexer, all I need to run now is this command pnpm envio dev. And what's going to happen is very quickly it's going to set up a database for me, and it's going to run my auto-created indexing code and start indexing. You can see there's 19 million blocks. It's just already gone through 12 million blocks on Ethereum mainnet, gone through another 5 million. Now it's started finding events, and it's processing events in this contract. And yeah, what you can see is it's indexing the events really quick. It expects to finish indexing in just a couple of seconds. We've got a really nice progress bar where we are in terms of blocks and how many of these deposit events we've indexed. And if we just let it keep running for another couple of seconds, you'll see that in no time we've absolutely smashed through and we've indexed pretty much every single event. There we go. We've indexed all 145,090 deposits into the eigenlayer contract. That was less than a minute. All of this information has been scanned and extracted through the 19 million blocks. Just the events we care about have been extracted, and they've been transformed and loaded into a database for us to query. So you can see over here at localhost, we can go query it. And if I just pop in a password, testing, you'll see here's our database actually where we can actually go ahead and look at all of this data. So if we look at the strategy manager and the deposit, here are all of the row-based entries that we have indexed into a Postgres database. We can see the strategy, the token, the shares. We can see who the depositor actually is, and there's a whole big bunch of these. As we said, 145,000 deposits with all that information nicely located over there. Now, what would you want to do with this? Well, there's many different things. You could use a business intelligence tool to examine this data, but really a primary thing you do after you've indexed the data is you have a rich GraphQL endpoint from which you can make queries and get data. So for example, if now I'm part of the EigenLayer team and I want to create a leaderboard showing the biggest deposits over the last 24 hours or anything like that, instead of having to go through 18 million blocks and try find all of those and then sort them and see what are the biggest ones, we have our real-time indexer that's indexed all of this information, and we could just structure a query where we say, if I just remove this, this can just be called my query as well. It can be called anything. For the strategy manager deposit, we could get 10 deposits. We could order them by, say, the shares descending, so the biggest amount of shares, and we could get who is the depositor, what are the number of shares, what is the strategy, and what's the token. And if you run this query, bang, you can see that response time almost instantly. You're getting the 10 biggest deposits ordered by the number of shares over here. You can very easily now see that information. And previously, if I had to ask you the question, well, give me the 10 biggest deposits, that would be generally quite something that's not necessarily super easy to answer. You would have to go through all 18 million, 19 million Ethereum blocks, look for the specific data, and then order it. And this just shows you the power of an indexer and what it allows you and enables you to do. So this GraphQL endpoint allows you to make requests with really nice annotations giving various limits ordering, so that for a front-end application you can have a very rich featured front-end application being able to give data related to the global aggregate of users, a specific user, many kinds of things like that, which is really nice. This is, of course, real time, which is really nice. So you'll see when the next new block pops up, there we go. It's indexed immediately and it keeps staying at 100%. And if there are any more deposits, that's immediately captured and updated in the database. There we go. You can see that ticking up again. So now getting on to the bit we promised, what's actually happening in the code that we can so conceivably possibly scan through 19.5 million blocks and extract 145,000 EigenLayer deposit events and put it into a database in less than a minute, in literally just a couple of seconds. What on earth's going on? How is this so easy? What is this magic? Why is there not an RPC? What's going on? So let's get into that. So I opened a code editor. This is what was auto-generated by the Envio command, and it's got quite a typical indexing structure if you've ever written an indexer before. And if you haven't, just to go back to this indexing section, technically what you have is a config, and the config is defining which data you want to fetch, so which contract, which events. Your handlers define how this data is processed, so when the deposit event comes in, do you just save it, do you do something? Your schema defines the shape of your data. So this schema is just defining the shape of our data, what it looks like. You can see this deposit, it's got a depositor, a token, the shares, a summary. This is this deposit item, and this corresponds to, if we look at this table over here, strategy manager deposit, you'll see these are the same columns over here that we see in this schema, right? So that's what's happening, and we can obviously edit all of this, create all of this. This is really a starting point. You can build extremely rich indexes that do amazing things, but this is just what's been generated for you right out of the bat. So again, yeah, this schema is the one part that's defining our data. You can see everything as an ID, there's a depositor, there's a token, there's a strategy. And then we will move over to the config, which, as we said, is defining essentially what data we're indexing. The start block can be sitting at 0 because, as you saw, it's so incredibly fast. We scanned through the first empty 17 million blocks that didn't have any events in a matter of 2 or 3 seconds, and that's thanks to hypersync, which we can get to, which you can leverage as well, besides using the indexer, which is a whole nother can of worms. But essentially, all we have here is we have the address listed that we want to index from. We have a pointer to how we're going to handle the events that we index, and we simply have a list of the events that we want to index. We want to index the deposit event, and this is what it looks like. So super simple, this config. The address and the events, and when you start getting to a multi-chain indexer and you're indexing more events from multiple chains, it can look a little bit more complex, but yeah, overall it's quite simple. And then we head to source over here, event handlers. You can see that's what we've specified, and this is the piece of code that's going to do stuff every time actually one of these deposit events is emitted. So when we actually see one of these deposit events and someone deposits on chain, then this event's going to be emitted and it's going to come hit our handler, and this code is going to be run. So I'm just going to minimize a few things. This initial summary is something that's been auto-generated and you can kind of just ignore for now. It's just showing a summary of how many events are being emitted. It's some boilerplate code, but here we really are. Here are the two pieces that I want to chat about. There's a loader and there's a handler. So there's these two pieces right over here. And there we go, just some nice linting. So what on earth is happening? First, let's ignore the loader for now. This handler is the main part and something that you might be very familiar with. What this handler is doing is it's saying every time there's an event, what exactly are we doing with it? And actually, to make things simpler, what I might just do is I'm going to stop the index and I'm going to remove this event summary. So Envio stop's going to actually delete the database and get everything cleared. And this initial event summary, just to make things easier, I'm going to actually delete it over here. And you'll see over here, I'm deleting it. In this graph schema, I'm going to get rid of this event summary. Let's just look at the deposits to make it even simpler. Cool, that looks good. Cool, we can see we're getting some errors. Don't worry about that. We don't want the summary. And we can get rid of that. And we can get rid of that. And now what I'm just going to do is run this command that when we make changes, pnpm envio code gen. If I ran pnpm envio dev, that would work too, but there we go. And pnpm envio dev. Now what's going to happen is going to be our same indexing, which we'll see will happen super quick. Looks like I failed to actually remove it from the loader, so very quickly, likely that caught it for me. There we go. Nothing needs to happen over there, so that's going to be removed. And I'm going to stop and start it again. And now it's going to be even simpler for you to reason with and me to essentially explain what's going on. So let me just run it again. I'll actually just run it in this terminal over here. It's the same terminal. And what you can see is actually happening is in this deposit handler, very, very simply, we are creating a deposit entity, and these fields, if we go back to our schema that we have for the deposit, we are simply populating these fields with information from the event, and we are then saving it. So I'll go through that slowly again, and just so you can see, busy scanning through now and very quickly going to index. But essentially what we do is this event over here, if you hit dot, you can see all of the information that's available. So every event that's being emitted, you can get its block hash, block number, block timestamp. You could get the log index, the source address, the transaction hash, or you could get the actual parameters. And on the parameters here, we could get the depositor, the shares, the strategy, the token. That's the decoded information that's actually been emitted from the event. You can see depositor, token, strategy, shares, and that information you could do anything with. You could save it, you could do this, you could do that. For us, we can see we are simply saving that information in the depositor field, in the token field, in the strategy field, and in the shares field. And then this deposit entity we made, we are simply saving. So this is an extremely simple indexer. It's getting in the deposit events, it's getting the irrelevant decoded event information, and it's saving it into the fields it needs to save it into before calling this .set property over here that actually saves it into the database. So that's a super simple indexer. You can see it's smashing through, getting those events very quickly. And just like that, we've indexed hundreds of thousands of events or eigenlayer, and it's very nicely indexed it into a database for us to use. So yeah, just another quick recap. The config is defining the address and the events that we want to index. The schema is a shape of our data, and the event handlers simply handle that data. Every time that event deposits emitted, this block of code is run, and this code is saying take those parameters from the events, put it into this data structure, and then save it essentially to the database. So very similar to an indexing framework, if you've worked with one before, how it would typically work. Now the loader is an optimization. You don't need to use it. But sometimes you actually want to load information that already exists from the database and modify it. So for example, if we started creating a user entity and we wanted to figure out the number of deposits from a user, what would happen is when we run this handler, we would actually load the user and we would increment the amount of deposits from that user. And this loader is just it's a really nice optimization to preload things in batches to ensure the index is extremely performant. So we'll get to that next time, but I think let's leave it there for now. As you can see, what we've done is we've indexed all of the data extremely quickly as if we were, the eigenlayer team. This is for the strategy manager. You've been able to see what exactly indexing practically looks like, how quick it is to do it, and the resultant database and API endpoints that you could use or integrate into your application. And again, it's extremely easy to follow this no-code quick start. And just like that, with what we've seen here, generate a useful indexer as the starting point to then keep on building. Cool. So without further ado, let's leave it there, and next time we will build upon this eigenlayer example.